So this is another lecture of inverse trigonometric functions. We have completed up to question number 2 from exercise 3.3. This is Maharashtra State Board textbook. Maharashtra State Board textbook. So let us solve this problem. The question is to prove that sine inverse of minus 1 by root 2 minus 3 times sine inverse of root 3 by 2 equals to minus 3 pi by 4. So we will begin with the left hand side. Left hand side is sine inverse of negative 1 by root 2 minus 3 times sine inverse of root 3 by 2. So what I will write? See, next step, sine inverse of negative x is negative sine inverse x. So this is minus sine inverse of 1 upon root 2 minus 3 sine inverse root 3 by 2. Okay. Now, by now we all have understood that if we have anything in inverse, if we have inverse trigonometric functions, so what is this? This is an angle, and this is also an angle. Which angle are these? Which angle is this? Which angle is this? It is the angle for which sine value is 1 by root 2. It is the angle for which sine value is 1 by root 2. Sine value is 1 by root 2. And which angle is this? Which angle is this? It is the angle for which sine value is root 3 by 2. Okay. And it has to be the principal value. So we know here this is negative, this is pi by 4. Sine inverse 1 by root 2 is pi by 4, and this is negative pi by 3. Pi by 3. So what will happen? This 3 and 3 cancel, so you have negative pi by 4. Negative pi by 4 minus pi. Negative pi by 4 minus pi. So this is, the answer is coming as minus 5 pi by 4. And what is RHS? RHS is negative 3 pi by 4. So I think there is a mistake in question itself. It has to be minus 5 pi by 4, not 3 pi by 4. So you will do the correction in the problem. What is the answer? The answer is minus 5 pi by 4. Okay, so here, so what should be the RHS? The RHS should have been, okay, the RHS should have been minus 5 pi by 4. This is correct RHS. Okay, you can copy this. Here we can write a explanation that sine inverse of minus x equals to minus of sine inverse x. This we can write. Rest all is self-explanatory, so no need to write any explanation. Now we go for question number 2. That is third second. In third second, we have to prove that sine inverse of negative half plus cos inverse of negative root 3 by 2 is equal to cos inverse of negative half. So what we will do, we will begin with LHS. In this, we'll have to solve both LHS as well as RHS. So here we have sine inverse of negative half plus cos inverse of negative root 3 by 2. Okay, so here sine inverse of negative half is negative sine inverse half. This is first you will do, plus Now see, for cos inverse of negative root 3 by 2, see what I will write. I will write here pi minus cos inverse root 3 by 2. Okay. So here I write the explanation for this. Sine inverse of minus x equals to minus of sine inverse x, and cos inverse of negative x is pi minus cos inverse x. Okay, this two you will write, since so we are using these two here. So for this, what I wrote minus sine inverse 1 by 2, and for this what I wrote pi minus cos inverse root 3 by 2. Now see the next step. Now as you know that these all are angle. This is an angle. What is this? It's an angle. And what is this? This is also an angle. So here I write. So this is negative pi by 6 plus pi minus this one is again, this is again pi by 6. Cos inverse root 3 by 2 is pi by 6. Why? Because cos pi by 6 is root 3 by 2. So you have here pi minus pi by 3. What do you have? See, minus pi by 6 minus pi by 6 is minus, it is minus 2 pi by 6, which is pi by 3. So this is final answer is 2 pi by 3. This is your left hand side. Now what I do is I go for the right hand side. So here I go for right hand side. Now let me solve RHS. RHS is cos inverse of negative half, which is equal to, once again, pi minus cos inverse half, which is equal to pi minus, and cos inverse of half. As you know, this is an angle. Cos inverse 1 by 2 is an angle. And what is that angle? This angle is pi by 3. So pi minus pi by 3 it is. It is pi minus pi by 3, which is equal to 2 pi by 3. So now what you have, therefore, LHS equals to RHS, and hence proved. Hence proved. We proved it. Okay. You can copy this. So now we have the third question, third. To prove that, see, to prove that sine inverse 3 by 5 plus cos inverse 12 by 13 equals to sine inverse 56 upon 30, 65. What we have to prove? We have to prove this. Okay, sum of these two equals to this. Okay, so let's begin with, so see what I will do here. I have to prove this. Now, as you know, to prove this, I will write next step as that is to prove that 56 upon 65 is equal to, it is equal to sine inverse 3 by 5 plus cos inverse 12 by 13. What I did, very simple. If I consider this to be theta, if this whole thing I consider theta, and this is, say, I consider this to be alpha. So what do I have here? I have theta equals to sine inverse alpha. So if theta is sine inverse alpha, what is alpha? Alpha is sine of theta. The same thing I have done. So this whole thing is theta, right? And here I have sine inverse of alpha. Here I have sine inverse of alpha. So if theta is sine inverse of alpha, what is alpha equal to? Sine of theta. So this sine is written here, okay? Very simple. So what was I asked to prove? What was I asked to prove? I was asked to prove that this equals to this, right? So to prove this equals to this is same as proving 56 upon 65 is sine of this. Now I will take left hand side. See, I will begin with left hand side. Left hand side is sine of sine inverse 3 by 5 plus cos inverse 12 by 13. Now look at this thing. What is it? What is this in form of? It's in form of, it is in the form sine of a plus b. It is in the form sine of a plus b. And you all know what is sine of a plus b equal to. Sine of a plus b is equal to sine a cos b plus cos a sine b. Right? Sine a cos b plus cos a sine b. So the next step here I get is, see, this is my a and this is b. So I will have sine of a cos of b, then cos of a sine of b, right? Like that I will have. So see what I have here, sine of a. So sine of sine inverse 3 by 5 sine a cos b, sine a cos b, cos of cos inverse 12 by 13 sine a cos b, now plus cos of a and sine of b, right? So cos of sine inverse 3 by 5, cos of sine inverse 3 by 5 and sine of cos inverse 12 by 13. Okay. Now see the next step. As you all know, sine of sine inverse x is x. So this is 3 by 5 and cos of cos inverse x is x. So this is 12 by 13. So this part we could write the answer faster, but here it is a bit of calculation required. So plus, now here I have cos of sine inverse 3 by 5, okay, and into sine of cos inverse 12 by 13. See, here we know the direct formula, but we would have to solve this in a different way. So see, how do I solve this? It is not at all difficult, so you don't have to worry. It will definitely take few steps, but then it can be solved easily. So I will solve this for you. So here, see, the next step I write, see, I write this as, this is my LHS, definitely, and this is my 1. Now what I do is, see, I need to work here on these two, this and this. I need to work on these two. So what I will do, first I will take this cos of sine inverse 3 by 5. So see, how do I go ahead? I write let sine inverse 3 upon 5 equals to theta. See, we all know that this is nothing but angle. What is this? It is an angle. Which angle? It is the angle for which sine value is 3 upon 5. Okay. Suppose if you know sine theta equals to 3 upon 5. So you will definitely be able to write that theta. Now here we are finding difficulty. Here we are finding difficulty sine inverse of writing sine inverse of 3 by 5. We are finding difficulty. We do not know sine inverse of 3 upon 5 because we are not knowing the angle for which sine is 3 upon 5. For example, sine inverse of 1 by 2. Now this one you don't find difficult. Why? Because you know the angle for which sine has value 1 by 2 and that angle is 30 degree, pi by 6. So this number is very important for us. This number is very important for us. If we know this number, if we are familiar with the number, we write the answer faster. Now here this number is 3 by 5. I do not know for which angle sine is 3 by 5. So I write that as theta. So let me write this as theta. So if this is the case, so 3 upon 5 is sine theta. 3 upon 5 is sine theta. Now you know that whenever there is an inverse function defined, this angle theta has to be, it has to be in fourth or the first quadrant. Okay, where theta is what? Now where theta is, you know, where theta is greater than equal to minus pi by 2 and less than equal to pi by 2, correct? But moreover, what you understand, see, minus pi by 2 to pi by 2. Now minus pi by 2 to pi by 2 is this. Okay, but moreover, you understand that here sine theta is positive. The sine theta being positive, now I am sure that theta is in first quadrant. Because if theta was in fourth quadrant, which could be a case, okay, for defining sine inverse function, the principal value can even be in fourth quadrant. But this case isn't working here. Why? Because sine of theta I am getting 3 by 5, which is a positive number. So now what I understand, since I understand here that it is positive number, so I write theta is where theta is greater than 0 and lesser than pi by 2. Theta is in first quadrant. Okay. Now, having understood this, now see what I will do. I will draw a triangle. I will draw a right angle triangle here. Let me draw one right angle triangle. See, you can do it by right angle triangle, or you can even do it by with the help of formula. That is also working. I can solve it by formula also. So see, sine theta is this. Now I will write therefore squaring both sides. So 9 upon 25 is equal to sine square theta. 9 upon 25 is sine square theta. Therefore 9 upon 25 is 1 minus cos square theta. Okay, because sine square theta is 1 minus cos square theta. So what is cos square theta? Cos square theta is 1 minus 9 upon 25. Cos square theta is this. Now I take the square root. What do I take? I take the square root. So when I take the square root, see what do I get? I will get here. Therefore cos theta is, okay, one more step I can write before taking the square root. So cos square theta is 25 minus 9, 25 minus 9 upon 25, that is 16 upon 25. So therefore cos of theta is plus or minus 4 upon 5. But as you know, theta is in first quadrant. Since theta lies in first quadrant, okay, therefore cos theta has to be positive. So what is cos theta? Cos theta is 4 upon 5. We got the value of cos theta as 4 upon 5. Okay, and do you remember, students, what that theta was? What was that theta? You had assumed theta to be this. Okay, so where you have theta, cos theta, you will write what theta was. So therefore cos of theta you will write sine inverse 3 upon 5. Got it? Equals to 4 upon 5. This is number 2. This is number 2. So what is cos of sine inverse 3 upon 5? 4 upon 5. Now, so as we, this one that I solved, okay, it was for this. It was for this. So what I will do is I will cover this whole thing in the same color. So here we solved for the first one. Now what? Now the orange one. Now the orange one. What is this orange one? Orange one is, we have to find sine of cos inverse 12 by 13. So what you will do? Very simple. You will assume now cos inverse of 12 by 13 as alpha. So if you take this as alpha, you will have to find sine of alpha. You will have to find sine of alpha, as you took this as theta and you found cos of theta. See, you found cos of theta. Okay. So let me begin. I will start writing as, let cos inverse of 12 by 13 as alpha. I will write let, okay, I will write here let cos inverse of 12 by 13 as alpha. Therefore, 12 upon 13 equals to cos of alpha, right? Now, once again, you know, whenever you define the cos inverse function, where should this alpha be? The principal value, you know, where alpha is greater than equal to 0, the alpha is greater than or equal to 0, lesser than or equal to pi. What does that mean? It means it is that principal value for cos inverse function is this. Okay, it is in either in first or the second quadrant. Moreover, you understood that cos of alpha you are getting here positive. Now, since you are getting cos of alpha positive, now you understand that this angle which you have, this angle which you have here, alpha, is definitely in the first quadrant. Why? Because had the angle been in second quadrant, if the angle had been this way, cos of alpha would definitely be negative. It would have been negative definitely. So here it is. So what do I write? Now I will be more, and I'll be more precise, and I will write alpha is greater than equal to 0, lesser than or equal to pi by 2. It is in first quadrant. Okay. Here also I'll write like this. So next is, so cos of alpha is 12 by 13. Now what I do, from cos alpha, I have to find sine of alpha. So I will write squaring both sides. When I square, I get 144 upon 169 equals to cos square alpha. Therefore, I will have 144 upon 169 equals to 1 minus sine square alpha. So sine square alpha is, therefore sine square alpha is 1 minus 144 upon 169. Therefore, sine square alpha is 169 minus 144. That is 25 upon 169. 25 upon 169. This gives us the value of, therefore sine of alpha is plus or minus 5 upon 13. 5 upon 13. Therefore, but then this alpha, as you have noted it down, alpha lies in first quadrant. So you'll write, therefore, you'll write here, since alpha lies in first quadrant, therefore you will have here sine of alpha equals to 5 over 13. Okay, this you write as 3. Wait, this is not 3. Now, what had alpha been? What had you assumed for alpha? It was this which you had assumed for alpha. So you will substitute it. So you will write, therefore sine of cos inverse 12 by 13. Sine of cos inverse 12 by 13 is 5 over 13. This is number 3. Now I can write using 2 and 3 in 1. Okay, using 2 and 3 in 1. So see here, what do I get? I will get there, I write here using 2 and 3 in 1, we get, what do I get? I get here, therefore LHS equals to, what was LHS? LHS was, see, this is 36 upon 65, multiply these two, 36, multiply these two, 65. So 36 upon 65, 36 upon 65 plus here what you have, cos of sine inverse 3 by 5, which is 4 by 5. So 4 by 5 into, and sine of cos inverse 12 by 13 is 5 by 13. Okay, so this is 5 by 13. You know, some students commit mistake of they will, they get tempted and they cancel this 5 immediately. Don't do that. If you do this, you will not get the required answer. It is not wrong, but you will not get the required answer. So the next is 36 upon 65 plus 20 upon 65, that is equal to 65 is common denominator. The numerator will be added, you will get 56. So this is your LHS and this was the RHS. You remember the required RHS was 56 over 65. So you got 56. So LHS equals to RHS, hence proved. I hope you all have understood this. You can again see this whole thing. Okay. So the way you solved the earlier one, as we solved this problem just now, okay, based on similar concept, as you solved this problem here, okay, based on similar concept, I give you an extra question. So you will all solve this. The way you solve the last problem, you will complete it on same line. It is cos inverse of 4 by 5 plus cos inverse of 12 by 13 equals to cos inverse of 33 by 65. So what you will do in the next step, you will write to prove this, that is to prove that, and you will take this cos inverse on the left. So what you will get? You will get cos of A plus B equals to 33 upon 65. And after that, you can solve this. Okay, so this is a practice problem you will definitely do. And I'm sure you will get the answer. Now we will solve question number. Now let's solve this one. This is third, fourth. So after third problem, now this is third, fourth from the textbook. This is exercise 3.3. So we have to prove that cos inverse of 3 upon 5 plus cos inverse of 4 upon 5 equals to pi by 2. Okay, so this question is a specific type of problem where you have two cos inverse. Remember, when you have two cos inverse and the right hand side you have to prove that it is pi by 2, or you have two sine inverse and the right hand side you have to prove that it is pi by 2. Both of these problems are of, they have the they have the same method for solution. So I shall now teach you how do you do it. If you remember, we have a very important property wherein we say that sine inverse of x, we say that sine inverse of x plus cos inverse of same number x is always pi by 2. So this particular property I'm going to use here. Okay, sine inverse of x plus cos inverse of x is pi by 2. What I see here, I have cos inverse of 3 by 5 and cos inverse of 4 by 5. So what I will do is from these two, I shall try to convert any one, maybe this or maybe this, either of them, it depends on you. You will try to convert one of the cos inverses into sine inverse. Convert this or this into sine inverse. Any one you will convert it into sine inverse. Okay, so see, how do I begin? I will start with left hand side. So left hand side here I have cos inverse of 3 by 5 plus cos inverse of 4 by 5. Cos inverse of 3 by 5 plus cos inverse of 4 by 5. And I write this as 1. Now, I decide to change this into sine inverse. So see, I will write let cos inverse of 3 upon 5 equals to theta. So therefore 3 upon 5 will be cos theta. And what I want to change this to sine inverse. So if I want to change this to sine inverse, I should first be getting the sine theta. First be I should first be trying to find sine theta. If I could get sine theta, then I'll be able to get sine inverse. Okay. So here I start writing. I will write here. So 3 by 5 is cos theta. Now I square both the sides. Okay. Moreover, you also know that if 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 you are writing if you are writing it this way, it means you have used the definition of cos inverse function. See, cos inverse 3 by 5 is theta. So 3 by 5 is cos theta. It means you are defining cos inverse function. Now, you know, for that, what should be the principal value where theta is in between 0 and pi. Okay, where theta is in between 0 and pi. But here looking at the cos theta value, it is very much clear that theta is in first quadrant. Where is theta? Theta is in first quadrant. So I will write here theta is in between 0 and pi by 2. Theta lies in first quadrant. Here theta is lying in first quadrant. Okay. So the next step I get is, see, I will write here now. Therefore, now I square both sides. What am I trying to get now? See, remember, I repeat whole thing once again. I said I want to get sine inverse here. Okay. So if I want to get sine inverse, what did I do? I took this thing as theta. Now from theta I got cos theta. So first I will try to get sine theta. Okay, what I will do, from cos theta I will try to get sine theta, because if I get sine theta, then I'll be able to get sine inverse. Okay, so 3 upon 5 is 3 upon 5 is cos theta. So 9 upon 25 is equal to cos square theta. 9 upon 20, squaring both sides. So therefore 9 upon 25 is 1 minus sine square theta. Therefore sine square theta is 1 minus 9 upon 25. So I get sine square theta as 25 minus 9. This is 16 upon 25. So I get sine of theta as plus or minus 4 upon 5. But as you have already said that theta lies in first quadrant, you will write since theta lies in first quadrant, okay, it lies in first quadrant. Therefore sine theta is 4 upon 5. Now if sine theta is 4 upon 5, so what is theta? Theta is sine inverse of 4 upon 5. And you know what theta you had taken as? You had taken theta to be cos inverse of 3 by 5. You had taken theta as cos inverse of 3 by 5. So what you can write? Theta was cos inverse of 3 by 5. So ultimately you get, therefore cos inverse of 3 upon 5, cos inverse of 3 upon 5 is sine inverse of, it is sine inverse of 4 upon 5. Okay, and what you will do, you write this as number 2. This is number 2, equation number 2 it is. And you will write using 2 in 1, using 2 in 1. I write here using 2 in 1, we get means LHS becomes, what will now LHS become? See, you have LHS as, in LHS you have cos inverse of 3 by 5. What do you have? You have cos inverse of 3 by 5. So cos inverse of 3 by 5 is now sine inverse of 4 by 5. So here you will write sine inverse 4 by 5. Okay. So you have LHS as sine inverse 4 by 5 plus, what is beside it? Beside it, it is cos inverse 4 by 5 only, plus cos inverse 4 by 5. Now, sine inverse 4 by 5 plus cos inverse 4 by 5 is pi by 2, which is a property. This is equal to RHS. Here I will write, what I will write? I write here, since sine inverse x plus cos inverse x equals to pi by 2. Okay, so we proved it. Therefore, LHS equals RHS. Hence proved. I hope you all followed it. Very simple solution it is. You can copy this, you can watch this again and learn it. The next one is to prove that tan inverse of 1 by 2 plus tan inverse of 1 by 3 is pi by 4. This is the easiest of all. I will start with left hand side, which is tan inverse of 1 by 2 plus tan inverse of 1 by 3. Now, as we all know, what is tan inverse of A plus tan inverse of B? See, we will write here. I can write here itself, you know, using tan inverse of A, tan inverse of A plus tan inverse of B equals to tan inverse of A plus B upon 1 minus AB, okay, when AB is lesser than 1. When AB is lesser than 1, we get, what do you get here? You get LHS equals to, what are we doing? We are using this property. We are using this property here. We are using this property here. So what will it become? See, we will get, LHS will become tan inverse of A plus B, 1 by 2 plus 1 by 3 upon 1 minus AB. That is 1 by 2 into 1 by 3. 1 by 2 into 1 by 3. So this will become tan inverse of, see, the LCM here is 6. So we'll get 3 plus 2 in numerator, and here 1 minus 1 by 6. 1 minus 1 by 6 we get. So it will now be, see, so you will have, which is equal to, tan inverse of 5 upon 6, and this is 6 minus 1 upon 6, which is again 5 upon 6. So that is equal to tan inverse of 5 by 6 upon 5 by 6 is tan inverse of 1, which is equal to pi by 4, which is RHS. I told you all that this is very simple. It is simplest of all. Okay, so here you can say, therefore LHS equals to RHS. LHS equals RHS. Okay, hence proved. Please copy this and we can solve the next one now. Yeah, this is pi by 4. Tan inverse of 1 is pi by 4. I wrote pi. Sorry for that. It's pi by 4. We all know tan inverse of 1 is pi by 4. Okay, so the sixth one is based on the same concept as fifth one. Here we have to prove that 2 times of tan inverse 1 by 3 is tan inverse 3 by 4. So I will begin with left hand side, and which is 2 times tan inverse of 1 by 3. I can write 2 times of tan inverse 1 by 3 as tan inverse 1 by 3 plus tan inverse 1 by 3. And then I will use the same property, that is tan inverse of A plus tan inverse of B, which is tan inverse of A plus B 1 by 3 plus 1 by 3 upon 1 minus 1 by 3 into 1 by 3. So this will become tan inverse of 2 by 3. The numerator will become 2 by 3, and this is 1 minus 1 upon 9. So the next step you get as, which is equal to tan inverse of 2 by 3 divided by 9 minus 1 by 8. That is 9 minus 1 upon 9. That is 8 upon 9. So this gets you tan inverse of 2 by 3 into 9 over 8. This is 3 and this is here 4. So that is equal to tan inverse of 3 by 4. So which is RHS? So LHS equals to RHS. Therefore, LHS equals RHS. Question number 7, we have to prove that in this third question, we are proving left hand side equals to right hand side. So there are several sub questions. Now we are on to 7th. See, the 7th question, we have to prove that tan inverse of, we have to prove that tan inverse of cos theta plus sine theta upon cos theta minus sine theta is pi by 4 plus theta. Okay, we have to prove this. Let's do it. I will begin with left hand side. I write here left hand side equals to tan inverse of cos theta plus sine theta upon cos theta minus sine theta. What I do next is I divide numerator and denominator inside the bracket by cos theta. Okay, so I write here dividing numerator and denominator by cos theta. So here we get what? Tan inverse of, you can check, cos theta plus sine theta upon cos theta and cos theta minus sine theta upon cos theta. This is what you will get. Okay. So here what we did, we divided numerator and denominator by cos theta. Okay. So cos theta plus sine theta divided by cos theta minus sine theta divided by cos theta. Now next step, I will separately divide by this cos theta upon cos theta, sine theta upon cos theta. So see what does this get me? So I will get, therefore LHS equal to, definitely everything is LHS. So here I get tan inverse of, I get here cos theta upon cos theta plus sine theta upon cos theta. And down here I get cos theta upon cos theta minus sine theta upon cos theta. So this, in the next step, cos theta upon cos theta is 1 plus tan theta divided by 1 minus tan theta. Okay, so now what I do here is this, see here I have 1, okay, and this is tan theta. Can I write 1 into tan theta? See, this tan theta, can I multiply 1 here? 1 into tan theta is still tan theta. So can I multiply 1? Yes. So when I multiply 1, the next step I will write tan inverse of this 1, and this 1. See, I shall be writing tan of pi by 4. So this is tan of pi by 4 plus tan theta divided by 1 minus tan pi by 4 into tan theta. Okay, so now this is in the form tan A plus tan B upon 1 minus tan A into tan B. So this is tan inverse. What is tan A plus tan B upon 1 minus tan A tan B? It is tan of A plus B. This thing is, this bracket here will become, it is in the formula form of tan of A plus B. This is tan of A plus B. That is tan of pi by 4 plus theta. So this is here tan of pi by 4 plus theta. So what do you have now? Tan inverse of, you have tan inverse of tan of pi by 4 plus theta, which is equal to pi by 4 plus theta, which is equal to pi by 4 plus theta, and that is your RHS. So you proved LHS equals to RHS, and that's the end. Okay, we are now left with one more question. So here we come to the last question of exercise 3.3. This will complete the inverse trigonometric functions, all the exercises. There are a few more problems which I will definitely come out with. Now let us solve this problem. This is to prove that tan inverse of square root of 1 minus cos theta upon 1 plus cos theta is theta by 2. So I will begin with left hand side. So here I write left hand side, very easy question. So tan inverse of square root of 1 minus cos theta upon 1 plus cos theta. And as you all know, 1 minus cos theta is 2 sine square theta by 2. We know this formula for ages. This we had been knowing for so long. 1 minus cos theta is 2 sine square. If you see 1 minus cos, what's the trick? The trick is whenever you see 1 minus cos, you should write 2 sine square. And you should write half of this angle. So it is theta. What you should write, you should now here write theta by 2. So 1 minus cos theta is 2 sine square theta by 2. 1 minus cos theta is 2 sine square theta by 2, and 1 plus cos theta is 2 cos square theta by 2. What you should do, when you see 1 plus cos, for 1 minus cos, what I said, you write 2 sine square. Likewise, for 1 plus cos, what you should write? You should write 2 cos square. And for this theta, you should be writing theta by 2. Okay, so the next step you get is, see, you get the next step as, therefore LHS equals to tan inverse of this 2 cancels, tan inverse of square root of tan square theta by 2. What do you get? Tan inverse of tan square theta by 2. That is equal to tan inverse of tan theta by 2. Tan inverse of tan theta by 2 you get. And what is tan inverse of tan theta by 2? This is equal to theta by 2. That was the required RHS. So you write this as RHS. So what you have finally, you have LHS equals to RHS, hence proved. Okay. We have completed this topic, students. All the best to you. Thank you.